Assalamu alaikum. My name is Mohammed Dassir. Today we will discuss the lecture number 10 of lecture number 10 part B of the last lecture that we have discussed before, in which we have discussed the Fourier transform and its main function and causes. Now we will move on to the Fourier transform and the discrete time Fourier transform. To understand the Fourier transform, you must know what is the Fourier transform. For that, we need to understand that Fourier transform is called the decomposition of time domain to frequency domain. Suppose we have a signal that has a frequency of 5 hertz, in time domain that can be represented like that, in the signal represented here. Then if we draw it in the frequency domain, it would have a spike of 5 hertz that could be represented as this signal. Now moving on further to discuss the Fourier transform, it has some formulas that could help us to understand and grasp the Fourier transform more accurately. The most general continuous form transform is xj omega is equal to minus infinity to infinity xt e minus j omega t dt. Now the formula for the discrete Fourier transform is x of t 1 over 2 pi minus pi to pi xj omega e minus j omega dt. Now the continuous Fourier transform is not much useful if as we have known it not studied much, so we will consider and focus more on discrete time Fourier transform. Now we would move on to the next lecture, next page, in which we have discussed and more about discrete Fourier transform. Now, what is discrete time Fourier transform? It is the question that it could be defined in a manner that it can convert the finite sequence of equally spaced samples of a function into same length sequence of equally spaced of DFT, FT. Like suppose we have a signal that has some function like that looks like that, in which there is equal spacing of the signal that could be like that, because in general when we are talking about real life signals it looks like more like that. So if we convert it into DTFT, it would look like that, from a 0 to 2 pi, in which we have transformed the signal into this signal. Now if we take the discrete Fourier transform of this signal, it would look like that, because it would have a spikes like that, which is the reason it is called discrete time Fourier transform. Now if we look at the formulas to find out the discrete time Fourier transform, it is the formula that has been derived mathematically from 0 to 2n minus 1 x of n e minus j omega n k divided by n. Now suppose we want to understand it more clearly and more appropriately, we would have considered a signal that is in front of us. X of 1 is equal to 1 at 0, minus 2 and minus 3 and 0, and it has n is equal to 4. Now to solve this question, to solve this signal, we must first consider the value of k, as it has 4 parts, so therefore it will have k equal to 0, 1, 2 and 2 and 3. Now if we put the first value of 0 into this function, into this formula that we have derived before, that would be 0 to 3 and x of n hjmn 2 pi 0 n. Now if this value of summation has been solved, it would look something like this, in which the x of 0 has a value, in which x of n 0 has a value and n has its value 0, and then x of 1 plus x of 2 plus x of 3 and all the other values would turn out to be 0, because n has a value of 0 that would automatically multiply with all the fractions and turn out to be 0. Now we have the function, we have the following values at the end of the day. When we solve the following equation, it would be equal to minus 4. The same procedure would be repeated for k equal to 1, in which the following procedure would be repeated, but there would be have a problem at e minus j 2 pi by t, in which there would be we will have to consider the mathematical equation in which e j omega t is equal to cos theta plus j sin theta, in which we will turn out cos pi by 2 is equal to 0, in which minus j sin minus pi by 2 is equal to minus j. So we will put minus 2, 0 minus j and minus 3 into the function, and it will turn out 0 plus 2j. As we have known before that we are only interested into the magnitude values of the following functions, so we will only take the magnitude values as given. So by taking the magnitude values, it turned out to be 2 under root 5 or 20. Now the same procedure will be repeated for k is equal to 2 and k is equal to 3 step by step, and if you follow the same procedure, it will turn out that k equal to 2 on k equal to 2 the value is equal to 0, and on k equal to 3 the value is equal to under root 20. At the end of the day, when we draw the function, it would look like this, in which the amplitude has a value of 0 at minus 4, 1 is equal to under root 20 and 2 equal to 0 and 3 equal to under root 20. Thanks for tonight.